Hello everybody and welcome back to Advanced Maths. Today we're looking at the area under a curve. We're going to find this using integration. So you can use integration to find the area between the curve and the x-axis. I'm going to show you what this means. So you've got a function y equals f of x here, and the area is given by this formula, the integral between a and b of f of x dx. So if you have 2 points A and B, and we can see this orange area here will be given by this function. Okay. Let's see an example. Find the area bounded by the curve y equals minus x squared plus 6x and the x-axis between x equals 1 and x equals 4. So this is this area here, between x equals 1 and x equals 4. So the area is going to be given by the integral between 1 and 4 of minus x squared plus 6x dx. We're going to have to integrate that, so let's just refresh how we integrate. If you would like more help with integrating, I have a video just about integrating that you can watch. So we first look at the power, the x squared, and we're going to add 1 to the power. And so it becomes minus x cubed. Then we divide by the power. Then we look at the 6x. The 6x is to the power 1. So we add 1 to the power, it becomes x squared, and then we divide by the new power. 6 divided by 2 is 3. And so we get this. Normally we put a plus c on the end, but when we find an integral with bounds, we ignore the plus c. Like this. Okay? So the area is going to be given by between 1 and 4 of this. And we write it with square brackets now because we have integrated the equation. So that looks like this, where we put 4, substitute 4 into the equation, and we substitute 1 into the equation, and then we subtract. So the upper bound substituted minus the lower bound substituted. Okay? You can type that all into a calculator. Just remember the brackets, be super careful with the brackets, and you should get the area is 24. Try typing that into your calculator and checking that you do get 24. If you don't, then you need to get used to using your calculator and you need to be careful with your brackets. The correct answer will be 24. Okay, you can use this same technique to find the area between two curves. So I've got two curves f of x and g of x here. I'm going to show you what that means. So let's look at f of x between minus 1 and 5. And the integral gives this the purple area. That's the integral between minus 1 and 5 of f of x. G of x, that's the blue area, will be this integral here. But to find the area between them, this orange area, you're going to subtract those two values. So the orange area is going to be given by the first integral minus the second integral. This is a common exam style question, so you should understand how to find the area between the two curves. Now, another thing to be careful of is negative area. So the green area here is below the axis, and that will give you a negative value. If you were asked to find the total area under this curve, like this, with the blue area and the green area, you could not just integrate between 1 and 4, because this negative area would subtract from the total area, making a smaller area. So what I would do is integrate between 1 and 3, and integrate between 3 and 4, and just make this area positive, and just add them together. Okay. So just be careful if you know your graph dips below the x-axis. Okay. Let's see some practice now. Find the area of the purple region bounded by the curves f of x equals 5x minus x squared and g of x equals x squared minus 5x plus 8. I've got these two curves graphed for f of x minus x squared and g of x equals x squared minus 5x plus 8. F of x is this curve up here and g of x is the curve on the bottom. You're going to integrate between 1 and 4 because that's where they intersect. Remember that g of x for this purple region is the one on top, so you're going to do g of x minus f of x. Pause the video now and give this your best shot. Do this on pen and paper with a calculator and see if you can get the right answer. Pause the video, and when you're ready, I will reveal the answer in 3, 2, 1. So the area under f of x is given by this. The area under g of x is given by this. When you evaluate those, you should get these numbers. And so the purple area is the bigger number minus a smaller number, which is going to be 9. And so the final answer should have been 9. It's a tricky question. If you struggled, maybe just try and find the f of x and see if you do get 33 over 2. And check g of x should be 15 over 2. Then all you do is subtract the bigger area from the smaller area and you will get this area left over. Okay, that's everything for today. This was a longer video than normal, so you may want to rewatch it a few times to make sure you understand every step. Thanks for watching, guys. Remember to comment, share and subscribe. If you have friends in your class who are struggling with this topic, then please send them the link to this video. If you have suggestions for future videos you'd like to see, please comment or email me at advancemaths@gmail.com. Thanks everyone, have a lovely day and good luck in your exams.